Hey, Callie. Okay, here we go. All right, so let's kind of start this over a little bit. Let me get it to focus. Okay, before we jump right in, let's talk about reference angles again, because I kind of just let that slide. We haven't needed a reference angle in quite a while, so we haven't really talked about them. So let's just talk about them again. Okay, so I actually took my time and made this handy dandy little chart here to not confuse anyone. Okay, so here's our little quadrants, right? 1, 2, 3, 4. Okay. Huh? No, I didn't. I promise. Hang in there with. This is what screwed me up. Okay, I got you. All right. So with this little chart, there's two things this does. This talks about reference angles and the actual real angle. Okay, so the reference angle, remember, is a little teeny tiny angle that's less than 90 degrees or less than pi over 2. So in quadrant 1, the reference angle is the actual angle. They're the same thing, okay? Now, over here in quadrant 2, all right, if you have the reference angle, you can do pi minus that to get the angle that belongs in quadrant 2, which is pretty handy. Or if you have the angle, you can do pi minus that to give you the reference angle. All right. If you need an angle in quadrant 3, and here's where it got squirrely, okay? If you need an angle in quadrant 3 and you have the reference angle, you can do pi plus the reference angle to get a quadrant 3 angle. If you have the real angle, then you're going to have to do the actual angle minus pi to get your reference angle. So this is what got us confused, okay, on here. Maybe not you, me, maybe Elizabeth, maybe not. Okay. Then over here in quadrant 4, 2 pi minus the reference is going to give you the angle, or 2 pi minus the angle will give you the reference, okay? So it's only quadrant 3 that has to have two separate equations depending on which one you have. Do you have the reference and need the real angle? Or do you have the real angle and need the reference? That's what was kind of messing me up a little bit of the other day, okay? So this may not be helpful to you, but we're going to come back to it in just a second. I just wanted to throw that up there, okay? So we'll come back to that. So here we go. Let's talk about the A first, letter A. Okay, we're going to need our calculators because it wants us to do calculator work. So remember, this is 14, this is 15. We want our calculator. We want to be in radian mode pretty much from here on out. Okay, so we have our nice little interval, right, that we're trying to find the values for. So if we're in this nice little interval and we want to know what angle of sine gives us 0.21, that means we're going to have two values, right? We're going to have two values. And since this is positive, we're looking for one angle in quadrant 1 and one angle in quadrant 2. Does that make sense since it's positive? Okay, so we're going to throw it in our calculator as the inverse sine of 0.21, okay? So if you're in radian mode and you put it in your calculator as that, you're going to get 0.212. That's one of those angles. This is the angle from quadrant 1, okay? That's the angle from quadrant 1. Everybody agree with that? Okay, that's going to be from quadrant 1. That's what the calculator gives you. All right, this happens to be the regular angle from quadrant 1 and the reference angle. It gives you both because in quadrant 1, they're the same thing. Okay, now we need the angle from quadrant 2, where sine is also positive. Okay, so how do I do that? I do pi minus the reference angle. Well, this is both. This is the reference angle and it's also the angle from quadrant 1. So to find quadrant 2's angle, okay, I'm going to take pi minus this, and I'm going to get 2.93. And those are my two values. Okay. That one good? Okay. And the reason that one was kind of so nice and easy is because this is the reference angle and the regular angle from quadrant 1. It's both. So it worked out so super nice. The reason this one is so confusing is because you're going to get the regular angle for one of your quadrants here. Then you have to find the reference angle. Then you have to plug it into the other quadrant. So it's multiple steps to find this guy. Okay. All right. So let's think about secant for a minute. So we know secant is actually going to be cosine, right? The reciprocal of cosine. So that's what we could also write this as. Then we know to find this in the calculator, we're going to have to put in this to find it. Okay. Now let's think about this. Sine being positive in one rotation was only quadrant 1 and quadrant 2. Where is cosine negative in one rotation? Quadrant 2 and quadrant 3. That's what we're looking at for cosine. Okay, so when you put this into your calculator, and if you want to see me do that, I can do that. We're going to do second cosine, 1 divided by negative 2.6. You can put your negative anywhere, and you get 1.97. Okay. This value that you got here is your quadrant 2 answer. That's what that is. So you immediately get one of your answers. Here's the tricky part. This is where things fell apart last time. All right, now I need to find the reference angle. He's not the reference angle. He was both because he was quadrant 1. Now I need to go to quadrant 2 and figure out how do I get the reference angle. So now find the reference angle for quad 2. Okay, so if we go to our little chart here, to find the reference angle, if I solve this for the reference angle, I'm just going to take pi minus my angle. It's the same equation, whether you have the real angle or the reference angle. Okay, so I'm going to take pi minus 1.97. Okay, let's see. I put that in my calculator and I got 1.18. This is my reference angle. Now that I have my reference angle, I can go to any quadrant I want and find the actual angle. Well, if I already have quadrant 2's value, I need quadrant 3's value, the actual angle from quadrant 3. Okay, so to find the actual angle from quadrant 3, I'm going to do pi plus the reference angle. That's going to give me quadrant 3's actual angle. Okay, so for quad 3, I'm going to take pi plus my reference angle. Okay, make sure everybody can see that. And I got 4.32. And that's your quad 3 value. Okay, so my math lab 14 and 15 should look just like these, so that you can kind of follow the steps. If you want to take a quick picture of this or write this down just in case something weird happens in my math lab and they get real wonky with you, you can. But this should kind of help you through. Does that make a little more sense now that we went over it? Yeah, it's this quadrant 3. It's because these two equations are so different. That's what had me weird. And so, okay, good. All right. Okay, well, then let's look at some identities. You're going to like these better. Students like these better. There aren't any numbers you even have to deal with. It's just all these lovely little, Lovely little equations. So, okay, identities are just like proofs. I know you've done these before. I remember seeing them in pre-calc, right? So you know an identity just means that both sides end up exactly the same. All right, that's your goal. Okay, so let's look at your tools from your little toolbox that you're going to want to use. Okay, first tool we have quotient identities. All right, and you've seen all these actually. None of these are new. So you know another way to write tangent is sine over cosine. Another way to write cotangent is cosine over sine. You may need that to help you get it into the form you want. All right, you know the reciprocal identities, right? You know that those other three are just 1 over the first three, you know, reciprocal identities. Okay, Pythagorean identities, these are so important. So here's the big one. The big one is the square of sine plus the square of cosine is 1. That's huge, okay? Well, you've also got two others, right? Now, these may be in a different order. My math lab might say to you something like secant squared theta minus 1 equals what? Well, the minute you see a square on a function, your mind should think Pythagorean. You should turn to this and say, okay, that would be tan square theta. All they did was rearrange it. So they like to rearrange the order a lot, and you just have to fill in what the other side should be, right? If I subtract 1 over here, I get tangent squared. So they put them in a lot of different orders. Playing around with these Pythagoreans is actually number 1 and number 3 on my math lab. So they're going to rearrange the order for you a lot, okay? They might also give you rearranged order for 3 of those. And then there's an extra that looks kind of like it might be Pythagorean-ish, but it's not. And so they'll ask you of these 4, which one is not an identity? And so you have to make sure, okay, these 3, they are, I see them, they're right from the sheet. This other one they made up. So that one's the one that's not an identity. So that would be like my math lab 6, I think is going to ask you, is it an identity? Is it not? Okay. Then these even and odds are going to be number 2 and number 4. And remember, we already know that these 4 on the sides are odd because they just pull the negative right from the theta right to the outside. These 2 are the ones that are even, because if they have a negative theta, it doesn't matter. It's going to be the same value as the positive theta, right? So these are the evens. These guys are the odds. So they're going to ask you to kind of fill in some of that stuff too. Okay, last thing that's important that from my math lab, number 5 is going to be this situation. And let's make sure we understand that. This is how students get in trouble. When you are given an identity to prove this side equals this side, you can't start screwing around with both sides. You pick one side to manipulate. You are not allowed to touch the other one. You are never under any circumstance allowed to do things to each side. That is a gigantic math proof no-no. So I think one of the questions on my math lab is like, is it okay to multiply both sides of an identity? No, you can't ever do anything to both sides of an identity. Only one side, always, one side only. Forget the other one, okay? So that's super, super important. Okay, so then let's talk about these rules. How do you know which side to mess around with? Pick the side that's the most complicated, because then you have more opportunity to do stuff to it. The crazier it looks, the crazier you can get, right? So don't pick the super nice, easy side. You pick the side that says like sine. What are you going to do with sine, right? Or 5. What are you going to do with the number 5? You want the crazy side because then you can do a lot of stuff to it. So pick the side that's more complicated, okay? So that's a huge lesson. Okay, sometimes if you're stuck and you can't figure out what to do, all right, take a quotient. If you have 2 separate divisions, 2 separate fractions, write them as 1. That helps a lot, okay, just a little tool. What if you have all kinds of different secants and cosecants and tangents and cotangents happening? Sometimes it's really nice to rewrite an entire side with sine and cosine. Those are the big ones, right? Change everybody to sine and cosine. Sometimes that'll help and things will start working out. But always keep that other side in the back of your mind. What are you trying to make it look like, right? And that will kind of help you choose your next step. Now, I know we're just starting out to do these in here, but this will get you really far, okay? All right, so let's jump on in. We're just going to do a bunch of examples. Examples that you are going to see exactly like this on your test and on your homework and on your quiz. Okay, so we clarified that the whole first page was my math lab 1 through 6. Well, this is 7, 8, and 9. Okay, right down the row. All right, so far we don't even have an equal sign. So we're not actually trying to prove anything right now. We're just trying to simplify. We're trying to make things look a little nicer. When it says simplify, it means take this to one trig function. And if possible, a trig function that's not a division, a quotient, okay? So this tells me to simplify for this little guy. I don't really know what it wants me to do, but one of my little hints to help was that if I have two quotients, what am I gonna do? Make one quotient, okay? That's simplifying, you make one. So let's do that, okay? So I notice here my denominators are not the same. All right, I'm gonna need an LCD. So I'm gonna close these off. All right, and just like with any other fraction situation, if these aren't the same, then I'm gonna need one of each for my LCD, right? So my LCD is gonna end up being one of each. Okay, now if I had an equal sign here, it would be fantastic because I could multiply all the tops and my fractions would disappear, but I don't have an equal sign. So I'm going to make equivalent fractions. I need to make each one of these have this denominator. So which one is this missing? Which packet? The 1 plus sine theta, right? So I'm going to end up multiplying the top and the bottom by 1 plus sine theta. Okay, I can make that look a little bit nicer, I guess. I could bring it down here. That's the new numerator. Here's my new denominator. Okay, there's my plus. I just multiply top and bottom. Okay, let's try this next guy. What packet is he missing? The minus one, right? Okay. Multiply him top and bottom by that. His new numerator becomes 1 minus sine theta. His denominator. Now, of course, you can write the terms in the denominator in any order you want to, right? I just decided that I was going to write them so they're in the same order, but you know it doesn't matter, okay? Well, now that they have the same denominator, I can write these as one chunk, right? One solid quotient. Okay, so here we go. My denominator is going to be the 1 minus sine theta, 1 plus sine theta. There we go. Okay. And then I'm just going to combine these numerators all in one piece. Now, if you can see that they start to cancel out and you can simplify them from here, that's fantastic. I'm going to add another step in though. I'm going to write everything together. I'm going to put 1 plus sine theta plus 1 minus sine theta. I just took my time and added that extra step in. All right. So what's going to happen in my numerator? What cancels out? Those cancel out, right? And we get 1 plus 1. That's a nice little 2. It's fantastic. Okay, what am I going to do in the bottom with these packets? I'm going to FOIL, right? You guys would FOIL those if you were in regular algebra. So 1 times 1, 1 times sine theta, negative sine theta times 1. Oh, those are going to cancel. Beautiful. and minus sine squared theta. Be careful now. Remember where your squared goes. Your squared doesn't go on the theta. Your squared goes on the word. When I multiply these together, I'm going to get minus sine squared theta. Okay. These are going to cancel. And I'm going to get 2 over 1 minus sine squared theta. Everybody okay with that so far? Now we're not done. It may look like, what else could we possibly do? But is everybody okay to that point with the foiling? Okay. Now, again, we're trying to simplify. Now you guys don't always know what that means, but you'll get in the hang of it. What it means to simplify is we want one denominator. That's it. So I told you, anytime you get a squared term, what are you going to do? You're going to go back and look at Pythagorean. So my denominator is 1 minus sine squared theta. So the only Pythagorean that contains a sine squared theta is this one. Could I replace this with a single squared term? Sure. If I subtract sine squared theta from each side, what am I left with? Cosine squared theta. Okay. So I could then say, okay, 2 over cosine squared theta. Okay. I could even keep going more because again, if you can get this to not have a denominator and not be a quotient, that would be fantastic. Don't worry about how to know when to stop. You're going to know when to stop eventually. Okay. So if I have a cosine in the bottom, now I know he's squared, but if I have a cosine in the bottom, is there anything else over here that has a cosine in the bottom that I could look at? Secant, right? That has a cosine in the denominator. Now I have cosine squared in the bottom. So that would be secant squared. Okay, so what I can do is make this 2 secant squared theta. And that's my answer. Why? Because 1 over cosine is secant. So 1 over 2 of those cosines is 2 secants, right? And so all I did was substitute this in, and then I have 2 times that. And that's where I end up with it. Because this is kind of like having, turn this over. It's kind of like having this, right? If I pulled that part out, which is kind of like having this, okay? So I just replaced this guy so he wouldn't have a cosine in the bottom. That's all. Is that okay? I know it's weird. It's weird. Okay. All right. Let's try this one. Okay. What if this thing is being all, sorry, not wanting to focus. Okay. All right, so now let's look at this next guy. This says it gives you really clear instructions. This one, this is nice because you're not left up to your own devices. So this says rewrite this quotient using sine and cosine. Okay, well, we know what cotangent is. You can flip back and look at that, but cotangent is cosine over sine. So there's that. And then if we rewrite cosecant in terms of sine and cosine, you can flip back and look at that, but he's the reciprocal of sine. I just rewrote them using sine and cosine only. Everybody okay with that? What do we see here that can cancel? Sine theta can cancel. If you don't see that, you can do a keep, change to multiplication, flip this guy down here. Otherwise, both denominators cancel, and I just have cosine theta over 1, which I really don't need, and that's my answer. And it worked out really nice. Okay, that one's a little bit better. Okay, let's try our next one down here. Okay, this one doesn't really want us to do anything except multiply. Okay, It just wants you to practice foiling these trig terms and then see what you end up as. Okay, so these are just kind of little pieces of future proofs that you want to be comfortable doing. So, you know, I like to seal everybody off. That's more than one term. Okay, so let's multiply these guys together. Okay, for the top, I'm just going to distribute, right? I'm going to do sine theta times 1. And then I'm going to do sine theta times secant. Okay, there we go. All right, we'll come back and deal with all that in a minute. All right, let's look at what's going on down here in the bottom. We're going to do 1 times 1, 1 times secant, negative secant times 1, and a negative secant squared theta. Okay, everybody got that so far? All right, well, I already see something that would cancel, which is kind of nice. Okay, so let's write this over. Sine theta plus sine theta secant theta all over 1 minus secant squared theta. Okay, now again, we're simplifying the best that we can. What do you do when you see a squared term? Where should you check? Pythagoreans. Okay, so this is 1 minus secant squared theta. Okay, so if I come up here, I have 1 minus secant squared theta this time. Okay, who could I put in place of 1 minus secant squared theta? Well, here's the identity. Okay, I want to make this look like this. Okay, well, let's see. I don't want secant squared theta minus 1. I want 1 minus this. So if I subtract secant squared theta over here, what am I going to have to do with tan squared? Subtract it over here. And then this is going to equal negative tan squared theta. Does everybody see that? I just solved it to make it look like this side. So I had to subtract him over here, which means I got to subtract him over there. Okay, so according to Pythagorean identity, my new denominator is going to be negative tan squared theta. That's going to be my new denominator. And he's negative because that's what I had to do to get my identity to match using that Pythagorean. Okay, is that all right? Okay, let's keep looking here. All right, here's another thing that's going to come with practice. When I look at this, there's one glaring term that bothers me, and the glaring term is secant, because here's the deal. Sine, cosine, and tangent, remember, they're the OGs, right? They're the original 3. Those other reciprocals, they don't really belong mixed in with the original 3. So I've got some sines, I've got some tangents. This guy doesn't belong. You don't need to mix reciprocals with the original 3. So let's change him into cosine and see what happens. Okay, so if I change him to a cosine, he looks like this. All right, there we go. Then if I clean it up and even more, this is what I see. Okay. All right, then I see this. Everybody okay with that? We're getting there now. We're getting somewhere. Because by getting rid of that reciprocal and putting in one of the originals, now I have tangent in the bottom. I got 2 of them and they're negative. What is this dude sitting up here also? Sine over cosine is tangent. That's tangent sitting right there waiting to be canceled out. Okay, so now normally we combine terms, right? We don't separate them. But in this case, because I see something that can be canceled, we're going to separate the terms. So I'm going to have sine theta over negative tan squared theta, okay, minus, where did I get the minus from? The bottom, right? Okay, I'm going to go ahead and change this guy into tan theta. Tan theta over tan squared theta. Okay. All right, this one's pretty wild here, so hang in there. I really need another piece of paper. I'll use, okay. All right. Now what I'm going to do is, remember, one of the little things that we talked about is when you seem like you're stuck, and I know I can cancel out a tangent here, but when it seems like you're stuck, change everything to sine and cosine, okay? Change it all to sine and cosine and see what you can end up canceling. So I'm going to have sine theta over, and you can make him negative. You can move the negative to the top if you want to, okay? Over, let's see, sine squared theta divided by cosine squared theta. Where did I get that? Well, tan squared theta. So I just changed it to sine squared theta over cosine squared theta. Okay. Now over here, I've got one tangent in the top and I have two tangents in the bottom. It's kind of like having an x in the top and x squared in the bottom. You guys know you can reduce that to this, right? You have an x cancel. So I'm going to have 1 over tan theta over here. Okay. All right. We're going to keep marching along. Okay. So let's clean this nonsense up a little bit. I'm going to change, and I'm going to flip. Okay. I did a keep, change, flip. All right. Now I see that I can actually work on this a little bit too. This again is one of these situations where over here I could pull out a sign. I could cancel this and one of those. So I could have negative cosine squared theta over a sine theta minus 1 over tan theta. Okay. I know this is just the never-ending problem. Hang in there. Okay. All right. We're going to keep on going here. What else could I do with 1 over tan theta so that it's not a fraction any longer? I could change him to cotangent, right? 1 over tan, I could change him to cotangent. Well, what does cotangent equal? Cotangent equals cosine over sine. Look what I have over here. What I have over here is actually a cosine times another cosine over a sine. If I really think about it, this is what I have here. I have 2 cosines in the top and I have 1 sine in the bottom. So I'm going to do negative cosine theta, cotangent theta, minus cotangent theta. Then you're done. That would be considered simplified. Okay, I know that was a lot of work, but that is what you would end up with, because now it's all one line. There aren't any fractions whatsoever all together, and that's where you end up. Okay, so I don't expect you to come up with this on a test and know when to stop and what to do and when to plug in. I just want you to be able to work through your homework using this information. When it comes time to your test proofs, I'm going to be very specific about this is the proof you have and this is where you're going to end up. Okay, so you know exactly where to stop and you're not just left out there in no man's land trying to figure out what to do. Okay. All right, are we ready for the next one? Okay. Here we go. Pretty good there? All right, I think you have to make a correction on this one. Let me see. Yeah, this little plus that's right here, make that a minus or he's never going to come out. Okay. make him a minus. All right, so this is going to be, again, these just work through your My Math Labs. They're not going to be exactly the same, but they're going to be close enough, 10, 11, 12 on this page, to get you where you need to go, okay? All right, here's what it wants us to do. It kind of is giving us more information now. We want to rewrite it over a common denominator. We can do that, find an LCD, combine it. Then it wants your answer in terms of sine and cosine only. That's it, okay? So let's do both those steps and see where we end up. Okay, well, first of all, we got to combine these. So what's my LCD going to be? He's going to be sine theta cosine theta. This is where I miss Ish. Y'all don't talk to me. Okay, so sine cosine. That's going to be our denominator. Okay, so I'm going to seal this little guy up here because I notice he's going to need to be multiplied by cosine. Cosine theta for both of those. So it's kind of like he would be stuck out here in front. We're going to get ready to distribute him, right? All over sine theta, cosine theta. Okay. Then I notice over here, I'm going to seal this off and I'm going to multiply both of these guys by sine theta. Okay, that's who he's missing. So I'm going to do that. Okay. I'm going to put his denominator in the same order as the first term. There we go. Okay, so we did what it wanted. We handled that. Okay, before we start worrying about, I mean, we already are in terms of sine and cosine. There's nothing left to change. Let's start cleaning him up, distributing, and putting everybody in one chunk. Okay, so I'm going to distribute this cosine through here, but I'm going to go ahead and I'm going to make one giant denominator. Now be super careful here because look at this second term. When you start distributing sine theta, you're not distributing just a sine theta. What are you distributing? A negative sine theta. So your signs are going to change over here. So my numerator is going to become cosine theta sine theta plus cosine squared theta. That's from the first one that I distributed. Minus, now I could put sine theta cosine theta, but I can put it in any order I want. And look what this first term happened to be over here. If I put it in the same order, then it's really easy for me to see they're going to cancel. And then I'm going to have plus sine squared theta. Okay. All right, so does everybody see that these two sines, theta, cosine thetas, they cancel? Okay. All right, let's see what we're left with. We're left with cosine squared theta plus sine squared theta over sine theta cosine theta. Okay, what's the rule when you see squared terms? Look at your Pythagoreans. So I have sine and cosine squared in the top. What does that actually equal to? The whole numerator. 1. The whole numerator is actually equal to 1. Okay, now this, if you're done, because they told you to leave your answer in terms of sine and cosine. A lot of time, if they didn't tell us that, I would tell you to turn this into cosecant times secant, because then you wouldn't have a denominator, right? You would just be a nice little non-quotient answer. But because they wanted it left in terms of sine and cosine, that's where you leave it. Okay, and you're done. Who is that? Oh, go back. Oh, here he comes. He remembered. Okay, I got nervous. I was like, who is it? It's a really polite little burglar. Okay. All right. Okay. Example 5. Here we go. We want to multiply and simplify. Awesome. So we're just going to follow directions. We're going to multiply, then we're going to simplify. Well, I see a FOIL thing happening here. Now you can't FOIL the -1. He's just stuck on the end. So we're just going to FOIL what we see in parentheses. So we're going to have cosine squared theta minus cosine theta sine theta. Oh, that's a minus, sorry. Minus Now be careful here. This says minus sine theta cosine theta. You can write that as long as you realize it's going to cancel with this term. So it might make it nicer if you just realize, okay, I could write it in the same order. Plus sine squared theta minus 1, stuck on the end, all over sine theta cosine theta. Oh, they're not going to cancel, my bad. Okay. All right, there we go. We don't have anyone that's going to cancel here. Okay, let's think about what we got. All right, well, first of all, I see squared terms. So if we go back and look at Pythagorean, what's cosine squared theta plus sine squared theta? What do these two equal when they're added together? 1. So this is like having a 1. Then I notice these are the same term. So that's going to be minus 2 cosine theta sine theta. And we still have the minus 1 in the back. Okay. Everybody okay with that? Okay. All right. Well, what does 1 minus 1 give you? That's 0. They cancel. Okay. Now let's pay close attention. We have negative 2 cosine theta sine theta in the top. In the bottom, we have sine theta cosine theta. I can rearrange their order, right? Cosine theta sine theta, I can make it look just like my numerator. And then what cancels? That. And what am I left with? An actual number, negative 2. And there we go. Okay, does everyone kind of get in the hang of what to do and what we're doing? Okay, so here these cancel. So I had negative 2 cosine theta sine theta. Just rearrange this order, cosine theta sine theta. These canceled, and I'm left with just the negative 2 there. And that's it. Does that make sense? Everybody kind of seeing something that they could grab onto? I know it's super exciting. Y'all are just riveted. Okay. All right, now a good old factor. Oh my gosh. Okay, do we remember how to factor? Because when I look at this, I see a squared cosine, a single cosine, and then a number. What is that? Quadratic. Got a quadratic numerator and a quadratic denominator. I cannot be crazy and go in here and start canceling cosines. And when I look, this does not have a GCF in the top or the bottom. So there isn't anything I can do except factor. I need 2 packets for the top and 2 packets for the bottom. That's all I can do. Okay, if you are stuck and you're not happy with the cosines, remember, you can rewrite this. I can replace x squared or x with your cosine. And I can turn it into this situation. And then you can go back and plug it in at the end. You can always do that. All right, so let's start factoring. This is that tough factoring where it's not a monic, so it's not a 1 in the front. You're going to have a little bit of work to do. We did this, when was it? Was it yesterday? No, we did this on Wednesday a little bit, where if you're stuck and you need a little help with how to factor this, you know, I have kind of a wonky way I do it. But if you learned it differently and you want to do it that way, you can definitely do that. But here we go. Let's factor the top first. Okay, so remember, my way that I do it is I take A times C. So I would take 10 times 2. That gives me a 20. Then I list all my factors of 20, right? And I find which factors of 20 are going to add together to give me the middle one, 4 and 5, right? So then I'm just going to replace, and you can do it in any order you want. It certainly doesn't matter. You can do 5x plus 4x, or you can do 4x plus 5x. All I did was separate 9x. That's it. Okay. And then once you've done that, I'm going to group. I see a GCF here of 2x, so that's what I'm going to divide out. I get 5x plus 2 in that little parenthesis. over here, because of the order that I put them in, I don't have a GCF. If you put them in the other order, you have two very nice GCFs. All I can do here is pull out a 1. Okay. And then when I finish grouping, that's what I have. So my new numerator is going to be 5x plus 2 in one packet and 2x plus 1 in the other packet, right? However you did that, you can put them in either order. It's up to you. Okay, now I'm going to take this 2x squared plus 3x down here kind of out of the way. I know that I write too big. I didn't leave you a whole lot of room. Okay, a times c is 2. Well, there's only one way to get 2. It's 1 times 2. That's what's going to give you the 3 there, right? So you can put them in any order you want. If you put them in the other order that not what I did, then it falls out nicely. You actually get a GCF. I don't get a GCF this way. Okay, I can pull out an x. Whoops. That's going to give me 2x plus 1. I don't have a GCF here, so I just pull out a 1, right? That's my little checkpoint. Finish my grouping. There we go. So if I go back and put those in for my denominator, that's what I get. I just went back and put those in for my denominator. Everybody okay getting to this point? So you factored the top, you factored the bottom, you got everybody in there, right? All 4 of those in some way or another. Okay, this was for the top, this was for the bottom. Are we okay? All right, then I notice these cancel. And I've got a numerator of 5x plus 2 over x plus 1. Nothing I can do with that. So I would normally be done, except that I didn't start out with x's. What did I start out with? Cosine. So 5 cosine theta plus 2 over cosine theta plus 1. And you get to stop there. Okay.
I'd rather do that.
That's crazy. Okay. So that's kind of the practice leading into the identities. Okay, that's your practice leading into them. Does that sound okay so far? Okay, now I'm going to pull up my MathLab 13 and 14 because I kind of want to show you they baby step you in starting with 13 and 14. Okay, so let me switch over my little recording people. We're on my MathLab 13 and 14, so you'll just have to listen along here and figure it out. Okay, so 13, 14, and I think 15 on your My Math Lab, it's the first time you've had an equal sign where you actually have to make one side equal the other side. Follow the directions really carefully. Don't get carried away. So 13 says, here's what we have. They want us to establish the identity. Your instructions say, write the left side in terms of sine and cosine. Well, this is already in terms of sine, so I don't have to do anything. How do I write secant in terms of sine or cosine? Well, he's just, let me move this. Okay, so he's just going to be 1 divided